Hi students, this is Mr. Yao. Today we're going to talk about 7.6 where we will learn about equations of circles. Before we start with circles, let's actually review something that we have learned in Unit 4, which is complete the square. So first, when we see something like this, x squared minus 10x plus c, we're trying to find a number plus c to actually make this whole thing a perfect square. The formula was 3 squared plus or minus 2ab plus b squared equals a plus or minus b squared. So the number we're actually trying to find is right here, this final number at the very end. If you recall, here's what we're going to do. Because this negative 10x is basically our 2ab right here. So we're going to find our b from that. Our leading coefficient is a 1, so that means our a is always just an x. So all we need to do is take this middle number, negative 10, divided by 2, which is negative 5, and that is going to give our b. However, our c is actually going to be b squared, which is negative 5 squared, which is 25. So that's the first one. All we need is the number 25 to make a perfect square. Of course, after we make the perfect square, it's going to look like x minus 5 and then squared. It's just this part. Number 2, we're going to do the same thing. Take the middle number, 8, divided by 2. That's going to give us a 4, which is our b. That means our c is going to be b squared, which is 16. So after we do the square, that's going to become x plus 4 squared. So basically add this b right there. Number 3, same thing. Take the middle number, negative 5 divided by 2. That's just going to be negative 5 over 2, which is our b. So our c is going to be b squared, which is negative 5 over 2 squared. Remember, when a negative number being squared, that's going to become positive. So it's just going to be 5 squared, which is 25 on the top, and 2 squared, which is 4 on the bottom. As for the final thing, after completing the square, it's going to look like x minus just a b minus 5 over 2, then the whole thing squared. That's what we learned about how to complete the square. Now let's actually use complete the square to solve equations. So next, we are going to first move this number over so that we can actually add something extra to complete the square. We're going to have x squared plus 12x, then leave a blank, equals to negative 32. So next, we are going to find whatever number we need. So we're going to take the middle number, 12 divided by 2. That's going to give us 6, which is our b. This number we need right here is going to be 6 squared. So we're going to add 6 squared on both sides. It's going to be the b squared. We have x squared plus 12x plus 36 equals on the right side negative 32 plus 36. That's a 4. The left side, if you recall, we don't have to do anything but factoring. We can just take this number, put it inside a parenthesis with that number, with x. So x plus 6 squared equals to 4. Now we're going to square root both sides. Square root, square root. We got x plus 6 equals plus minus 2. And we're going to subtract 6 on both sides. We're going to either get a positive 2 minus 6, which is going to be negative 4, or we're going to get a negative 2 minus 6, which is negative 8. So these two are going to be our final answer for number 4. Let's try another one, number 5. Let's do the same thing. First, move this number over to the other side. So we got x squared minus 8 over 3x. A blank equals negative 5 over 3. And if you want to make sure you actually balance both sides, you can also do another blank right there. Next, we're going to find our b. We will take the middle number, so negative 8 over 3 divided by 2. That's going to be negative 8 over 6, which is going to be negative 4 over 3. You can just type in your calculator to get that. That's our b. And now we're going to actually put it back right there. That's going to be the b squared. So negative 4 thirds squared is being added. Add negative 4 thirds squared. So left side is going to be x squared minus 8 over 3x. Then negative squared is positive, so plus 16 over 9. The right side is going to be negative 5/3 plus 16 over 9. That's going to be negative 15 over 9 plus 16 over 9, which is 1/9. So that's the right side, 1/9. Again, we don't need to do any factoring. We can just take this number right there and put it inside the parentheses with an x. So x minus 4 over 3 squared is going to be 1/9. We're going to square root both sides. We're going to get x minus 4/3 equals plus minus 1/3. Because when we square root 1/9, we're going to get plus minus. So final answer, we're going to separate them. So x either equals a positive 1/3 plus 4/3. That's going to be 5/3. Or x equals negative 1/3 plus 4/3. That's going to be 3/3, which is 1. So these are our final answer. That's the review for completing the square. Now let's move on to the actual circle stuff. When we actually have put a circle inside a coordinate system, we have two different situations. One, when a circle actually centers at the origin. So that means this is the center, and to every single direction, these are all just R. That's R, these are all just R. So we want an equation to actually represent the circle. And the circle is actually this all surrounding, the surrounding part, not the including the axis. So we want to represent any point on the circle. It could be anything, like anywhere on the circle. Something very special. For example, I put a point right there. I can actually have the x coordinate and the y coordinate. And we kind of see, oh, wait, they actually form a right triangle if I just connect the radius. And that's our relationship for a circle. We actually connect the x, connect the origin with the point, they form a radius, they also form this right triangle. So we can use Pythagorean theorem to present when a circle is centered at the origin. It's going to be x squared plus the y squared equals r squared. Next, if we have a circle center at hk, so let's call this point hk, right there. Now we want to represent the circle with any point around this hk, which is going to be slightly different. This time is not connect to the origin, but if I still do something, I still draw these lines, I still draw these like grid kind of lines. Let's say this point is actually x, y. We can actually still look for some relationship. The horizontal coordinate is x, this point is h. So this part can be represented by x minus h. And this part could actually be presented as y minus k. And that is still a right angle, which means I can still form a right triangle if I connect these 2 points. That is my radius. Which is why if a circle is centered at hk, I can still write down the Pythagorean theorem, x minus h squared plus y minus k squared, that equals to r squared. So now let's actually look more closely in a clearer graph. So that's the first one, and that's this one, which tells us the standard equation of a circle is going to look like this. X minus h squared plus y minus k squared equals r squared. So this is the equation we're going to be working with for circles. Something I want to emphasize on. So for example, even if you see this point as say like 3, 4, it's going to be minus 3 and minus 4. It's always going to be the opposite. It's kind of the same as when we were solving equations. When we want to put it back in, we're going to use the opposite number because it's minus whatever that number is. Now let's practice. Write the standard equation of a circle. First, the circle is centered at 0, 0. So real quick, if you actually look at it, the first one, the center is 0, 0. That just basically means my h is 0, my k is 0. So I put it in. That's x minus 0, that's y minus 0. Basically is x squared plus y squared equals r squared. So circle center at the origin is just a special case of the standard equation of a circle. So the first one, I can still use it. X minus 0 squared plus y minus 0 squared equals to the radius squared, so 2.5 squared. Now I'm going to simplify it, no minus 0, so x squared plus y squared just equals to 6.2. Hey, that's A. Next, B. X minus, I'm going to keep it, minus -2, because that's my h. I just need the opposite. You can just go directly to plus, but I'm just going to do the equation way, the minus whatever the number is, squared, and plus y minus 5 squared equals to the radius, which is 7 squared. Simplify it, x plus 2 squared plus y minus 5 squared equals 49. That's B. Next, C. X minus 0 squared plus y minus -9 squared equals to 4.2 squared. And now I actually need to simplify the whole thing. I still don't need to write that 0, so it's going to be x squared plus y minus 9 squared. And now I'm going to need to figure out what is 4.2 squared. That's 17.64. That's C. Next, D. X minus 7 squared plus y minus -9 squared equals to 1 squared. So x minus 7 squared plus y plus 9 squared equals 1. That's a standard equation of circles. Now let's practice the other way. If you're given an equation, how do you actually identify and draw the circle? So let's have a look. The first one. We can see the numbers are -4 and 2. I need the opposite number for my actual center. So the opposite of -4 is 4. The opposite of 2 is -2. As for my radius, since this is r squared, that means my radius is going to be the square root of 36, which is 6. So 4, -2 is at 4, -2, right there. And I need my radius to be 6. So this is my center. I need the radius 1, 2, 3, 4, 5, 6. That means that's got to be a point on the circle. 1, 2, 3, 4, 5, 6. That's another one. 1, 2, 3, 4, 5, 6. That's another one. 1, 2, 3, 4, 5, 6. So these are 4 points. I'm going to roughly connect them to actually make a circle. Just kind of connect them, make them look like a circle. Doesn't have to be super precise. Kind of where my circle is going to be, with a radius of 6. B, I need the opposite number again. The opposite of -3 is 3. Y doesn't even have a number, which means it's got to be 0. 16 is r squared. That means my r is the square root of 16, which is 4. So that's 3, 0. And the radius is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I can just roughly connect them to kind of make a circle. Next, the opposite number of 5 is -5. Opposite number of -3 is 3. Since that is r squared, square root of that is going to be 3. That's my radius. So -5, 3, right there. That's the center. 1, 2, 3, that's my radius. 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 And I could just connect them to actually form my circle. That's example 2. Next, the point 11, 10 is on a circle with center 17, 9. So it's kind of easy to set up the equation. It's going to be x minus 17 because x minus whatever the x coordinate is squared plus y minus 9 squared, which equals to, currently I don't know my radius, r squared. However, if you think about it, this is the point on the circle, that's the center. From any point to the center of the circle, that's actually a radius. So that means in order to find my actual radius, I need to find the distance between these 2 points. So the distance, I use the distance formula, that's going to be 9 minus 10 squared plus 17 minus 11 squared. That's going to be square root of 1. squared plus that's 6 squared, which is square root of 37. So my r is actually the distance, which is square root of 37. If I want to square that, that's just going to be 37. So my final equation, x minus 17 squared plus y minus 9 squared, is going to equal 37. That's example 3. Now let's practice more. Same thing on example 4. Set it out first with the center. X opposite of -1 plus 1 squared. Then y the opposite of 3, so minus 3 squared equals r squared. Again, my r is going to be the distance between these 2 points. So -1 minus -5 squared plus 3 minus 6 squared. -1 minus -5, that's just -1 plus 5. So that's going to give us 4 squared. 3 minus 6 squared, that's going to be 3 squared, which actually is going to be 5. Now I just replace r squared with 5 squared. So my final answer, x plus 1 squared plus y minus 3 squared, is going to equal 25. So now we have a question. These two problems, they're given, you're told the point is actually on the circle. What if you're trying to decide if a point is on the circle or not? That means you have an equation, you're just trying to decide if it's on the circle. All you need to do is plug the numbers in to make sure the left side actually equals the right side. Now let's move on. Example 5. And this is something slightly different. Let's talk about the epicenter of an earthquake. You know, an earthquake, when you have a center, it's actually going out as circles. So that's how like the wave is going to go out. So this question, when you're given the epicenter is 7 miles away from this point, that's basically saying you're forming a circle with center A and the radius being 7. So now let's try to do that. -2, 2.5 is right here. That's my point A. 7 away from it, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And that is 2.5, so 7 away is going to be 9.5. And 7 down is going to be -5.5. Actually, -4.5. We can connect them to kind of make a circle. Roughly, doesn't have to be super precise. But since we still need to draw the other circles, let's try to be somewhat precise. That's A. Next, B. B is at 4, 6. 4, 6, right here. And that's 4. So 1, 2, 3, 4, 4, 4, and 4. So that's my circle right there. That's my circle right there. Next, 3, -2.5. 3, -2.5, which is right here. My radius is 5. So 1, 2, 3, 4, 5. Left side right there. Number is at -2.5. So go down more 5. That's -7.5. And go up. That's going to be 2.5. I can draw my circle. Kind of like that. Not as precise, but you can see all 3 circles actually meet at one point, which is right here. And that point is 5, 2. And that is going to be the actual epicenter for the earthquake. Next question, why are three of these graphs needed to locate an earthquake's epicenter? And I'll let you pause and think for a second. Hopefully you have thought about it. Well, because when you actually draw 2 circles, they're going to meet at 2 points, not just 1 point. So we can't exactly pinpoint where is the one epicenter of the whole earthquake. So we need a 3rd circle so that they can actually intersect at exactly 1 point. That's example 5. Next, example 6. A circle with center 7, -5, and is tangent to x equals 9. So this time, same thing. You are told I have this x opposite of 7, so -7 squared plus y plus 5 squared equals r squared. But I'm not told where r is. So let's think about it. 7, -5 is right here. The line x equals 9 is right here. Saying that line is actually tangent to the circle. So if a line is tangent to a circle, that means at the point of tangency from the center, that's going to be the radius. So this is going to be the distance of the radius, which is actually 2. So my r is going to be 2. Final answer, x minus 7 squared plus y plus 5 squared equals 2 squared, which is 4. That's example 6. Next, example 7. Same idea. The center of the circle is -5, -2. Right there. I'm going to write my initial equation. -5 opposite, so plus 5 squared. Opposite of -2, y plus 2 squared equals 2 r squared. Now I need to know where is y equals 3. Y equals 3 is actually right here. If you're like, wait, but how come y equals is actually a horizontal line? Well, because y equals means the line is crossing at 3 on the y-axis. Because every single point on this line has a y-coordinate at 3. That's why we use y equals 3 to represent. So same idea. This tangent line, I'm going to draw distance. That's 1, 2, 3, 4, 5 away, which means my r is going to be 5 squared. So x plus 5 squared plus y plus 2 squared equals 25. That's example 7. Next, example 8. A circle has end points of the diameter as 0, 13, and 10, 5. Write the standard equation of the circle. So this one is slightly different. We know the end point of a diameter. Let's just kind of draw a circle that we can have a look. Let's say these are the end points of the circle, which makes the diameter. You can see the center is right there. So the center is actually the midpoint of the diameter. So I'm basically finding the midpoint of these 2 points. Center C would actually be 0 plus 10 divided by 2, 13 plus 5 divided by 2. I'm just averaging their coordinates. It's going to give 5 and 9. Next, I'm going to need to find my r. So if that's my center, I can at least set up the equation as x minus 5 squared plus y minus 9 squared equals r squared. Next, my r is actually not going to be just that. Because that's a diameter, if I find the distance between these 2 points, that's going to give me my diameter, which is d, which is 2r. That's going to equal to 10 minus 0 squared plus 5 minus 13 squared, which actually is going to be 100 plus 64, which is square root of 164. If you simplify that, that's going to be 2 square root of 41, which means my r is actually going to be square root of 41. So when I square it, that's just going to be 41. My equation is x minus 5 squared plus y minus 9 squared equals to r squared, which is 41. That's example 8. Next, example 9. Same idea is a diameter that's given, so I need to find my midpoint, which is c equals -6 plus 2 over 2, and then 8 plus 10 is going to give me -6 plus 2, that's -4 over 2, -2, then 18 over 2, that is 9. So I can set up my equation, which is x plus 2 squared plus y minus 9 squared. Again, if I actually calculate the distance between these 2 points, that's going to give me the diameter, which is twice of radius. So 2 minus -6 squared plus 10 minus 8 squared. That's going to give me 2 plus 6, so 8 squared, and plus 2 squared. That's 64 plus 4, that's square root of 68. It's going to be 2 square root of 17 if you simplify it, which means that r is going to be square root of 17. So when I write the equation, I need r squared. That is just going to be 17 on the right side. So I copy everything down. X plus 2 squared plus y minus 9 squared is going to equal 17. That is example 9. Next. This time we are going to, we're given equation of a circle, but they're not exactly in the standard form. Again, the standard form look like x minus h squared plus y minus k squared r squared. That's the standard form. This doesn't look like that. The process to change from what we have into standard form is going to be complete the square. That's why we reviewed at the very beginning. So now let's have a look. First thing I'm going to do is I'm going to group all the x together and actually leave a blank so that I can actually put them in the squares. So I have x squared plus 12x, leave a blank. I'm going to put all my y together. That's y squared plus 10y, leave a blank. I'm still going to move my number to the other side. So that whole thing equals to 3. Of course, I need to put on some extra numbers. But now let's find what number needs to go into the first blank. This middle number, 12 over 2 is going to be 6. And I need, which is our b, and I actually need b squared. So that's got to be 6 squared. As for the other one, this is a 10. So 10 divided by 2, that's going to be 5, which is going to be here. I need 5 squared. As for the right side, since I added the 6 squared, I'm also need to add it to the right side. And I'm also going to need to add 5 squared. Now let's actually put them into the form. I don't need any other number. Oh, don't forget the plus sign. I don't need any other number. I just need this to put in the parentheses. X plus 6 squared. And then for the other one, I just need this number to put in the squares. Plus y plus 5 squared. On the right side, it's going to be 3 plus 36 plus 25. So that's 36 plus 28, which equals to 64. Now I have the standard form. I can identify my center, opposite numbers of the 6 and the 5, so -6, -5. And the radius is going to be the square root of the 64, which is, that's example 10. Example 11, same idea. I'm going to need to copy everything down, but before I actually do that, I'm going to move all the variables to the left side, and I only leave this one number on the right side, because as you can see in the standard form, the x is on the left side, y is on the left side, the right side is just r squared, which is going to be a number. So I have x squared plus 24x, leave a blank. The y move over is going to be plus y squared. And I still need to move the negative 30y over, so plus 30y, and leave a blank. The right side is going to equal negative 353. Now it's time to figure out what number I need. Middle number, 24 divided by 2, that's 12, and I need 12 squared. 30, middle number divided by 2 is 15, and I need 15 squared. As for the right side, I need to add 12 squared. I also need to add 15 squared. Now the left side, I just need this number to put in parentheses. So x plus 12 squared plus I need this number to put in parentheses, y plus 15 squared equals to, the right side is going to be negative 353 plus 144 plus 225. That's going to be 369 minus 353, which is 16. So my center the opposite of this number and this number, so -12, -15. As for the radius, the square root of 16, which is 4. That is number 11. Next, number 12. So same thing, I'm going to need all the variables on the left side, so I need to move the 8x to the left side and put it together with the x squared. X squared minus 8x, leave a blank, plus y squared plus 10y, leave a blank, equals 11. Now it's time to find the values that I need. I have -8 over 2 is -4. You're going to square that. Remember, whenever you square a negative number, that's still going to be a positive. It's going to be plus 16. This is a 10 divided by 2 is a 5. So the number I need right here is going to be 5 squared. So right side, I'm going to need to add 16, then add 5 squared, which is 25. Next, put in parentheses. I need this number, x minus 4 squared, plus I need this number, y plus 5 squared. The right side, 11 plus 16, that is 27 plus 25, that's 52. So my radius is going to be, my center is going to be at 4, -5. My radius is going to be square root of 52, which actually is going to be 2 square root of 13 after simplifying the radicals. Next, number 13. X squared needs to go to the left, the y needs to go to the left, so I have x squared. Well, you see we don't have an x, so x squared is just going to be by itself. Plus y squared plus 20y. I still have a blank right here. The right side is -64. I don't need to do anything with my x squared, but I still need to do my y squared. That's 20 over 2, which is 10. So the number I need here is 10 squared. That's 10 squared. So I have x squared plus, again, I just need this number right here, plus y plus 10 squared equals 2. The right side is 36. Which means my center is going to be, since there's no number with x, that's just 0. Opposite of 10 is -10. My radius is the square root of 36, which is 6. Next, last one, example 14. Still the same. Move my y over, move my x squared over. So I have x squared plus y squared plus 2y. Leave a blank for the y's, equals 15. Number I have right here is a 2. So 2 divided by 1, 2 is 1. So I need to add 1 squared, so add 1 squared on the right side. Which means when I try to put them in parentheses, x squared plus, I need this number, y plus 1 squared equals 16. Which means my center is going to be at 0, -1. My radius is going to be at 4. So in order for us to graph a circle, we of course I need to identify the center and the radius. Center is at 0, 1, -1, 0, -1. Radius is 4, so 1, 2, 3, that's a point on the circle. 1, 2, 3, that's another point on the circle. 1, 2, 3, 4, that's another point on the circle. 1, 2, 3, 4, right there. So I have 4 points. I can roughly connect them to actually make a circle. And that is everything for 7.6. Thank you.